This is my latest Scratch project called Wallpaper. Essentially what it does is it takes a rectangle in the upper right hand corner, the first quadrant, and it divides that rectangle into a large number of very, very small squares. The size of those squares is controlled by 3 parameters that the user puts in. And then what the script does is it takes each of the coordinate points, x and y, and it squares x, squares y, adds the two together like the equation of a circle. And if the sum is even, it plots a point. If the sum is odd, it skips that point and moves on and computes the sum of the x and y coordinate squares for the next point. So let me run the program here. I click on the green flag. And those are the last inputs, so I'm going to try 1, 1, and 2. And I'm running in turbo mode, so it's computing very fast. But we see that essentially what's being computed is a series of concentric circles, very, very thick circles. Well, since we started with the equation for a circle, that's not terribly surprising. So let's try a couple of inputs that may surprise you. So I'm going to stop and select some more inputs. So let me try 10, 10, and 999 down there. So I'll go 10, 10, and then 999. The inputs are very arbitrary. You can put in whatever you want. Then all of a sudden, we have a much more complicated pattern than concentric circles. There seems to be some circles that are concentric, but they're quite differently patterned, and it's almost like a checkerboard. And so all of a sudden we have the motif of the circle squared plus the square squared. And this all comes about because of the relationship between these 3 parameters, the 3 inputs, and x squared plus y squared, the equation for a circle. Very, very interesting program. Every set of unique inputs generates a unique pattern. You cannot predict the pattern ahead of time. You actually have to compute it and then look at the pattern. That's the only way you'll ever find out the pattern. Very interesting, pretty simple algorithm. I have a PDF file for this one too, which gives much more of the detail of how the algorithm works.